Hello everyone. Now we are going to discuss about the Beckmann rearrangement. See, usually the rearrangement reactions just rearrangement only taken place. So here nothing will be eliminated. Just the position of the atoms will be changed. So one compound will be converted to another compound by means of rearrangement. Now we are going to discuss about the Beckmann rearrangement. What is this Beckmann rearrangement? It is the conversion of ketoxime into acetamide in the presence of phosphorus pentachloride under acidic condition. Here the reaction will come here. This is the conversion of ketoxime, that is R1C double bond NOH will be converted into R1CONH2. Okay, R1C double bond NOHR2, that is under the condition of acid, it will be converted into R1C double bond ONHR2. Ketoxime will be converted to amide. The mechanism of Beckmann rearrangement is as follows. The first step involved in this mechanism will be protonation. Here oxime we can see that one, that is R C double bond NOH R dash or R1 C double bond NOH R2 that will be protonated to give the compound hydronium, that is R C double bond NOH2 R dash. So this will give um, a compound, intermediate compound, that is Rn double bond Cr dash with the elimination of water molecule, that is OH2 will be eliminated, that is H2O will be eliminated, that is removal of water molecule will give the intermediate compound Rn double bond Cr dash. Uh, this we can write it as, instead of Rn double bond C plus R dash, that will be written as R N plus triple bond C R dash. This is interconvertible. Instead of R N double bond C plus R, we are converting R N plus triple bond C R dash. Here, water molecule will attack the carbon ion. The next step is attack of the water molecule to the carbon ion, which will give the intermediate compound R N double bond C R dash OH2. So the water molecule will be added to the carbon atom. So the next step is removal of proton. That OH2 group is present in that one. Proton will be eliminated. That is H will be eliminated from that intermediate compound. That R N double bond C R dash OH2. That H will be removed from that group. So which will give the compound R N double bond C R dash OH. So which will give the compound R N double bond C R dash OH, which will give after tautomerization, that will give that RNHC double bond O R dash, that is amide will be formed, that is R dash CONHR, that is a amide. So R N double bond C R dash OH, ketoenol tautomerism will be taken place. Here that OH will be converted to double bond O. One of the hydrogen will be added to the nitrogen. So it is converted to amide. So this is the mechanism behind the Beckmann rearrangement. That is, oxime will be converted into acid amide. The name itself will tell what is that reaction. Here this is a Beckmann rearrangement reaction. So here oxime will be converted into acid amide. So what are the applications of this Beckmann rearrangement? The main use of this Beckmann rearrangement, it is useful for the conversion of ketoxime into amide. That is, R C double bond NOH R dash will be converted into R dash CONHR. Amide will be formed. So it is useful for the conversion of ketoxime into amides, and it is also useful for the conversion of acetophenone oxime into phenyl acetamide. So it is also having another one application, that is it is useful for the conversion of acetophenone oxime into phenyl acetamide, and it is also useful for the conversion of benzophenone oxime into benzanilide. So this phenyl acetamide will be formed by the reaction of Beckmann rearrangement. Similarly, benzanilide is also formed from benzophenone oxime by the mechanism of Beckmann rearrangement. So this is the reaction, that is benzophenone oxime in presence of acetic anhydride, acetic acid and hydrochloric acid. So under acidic condition, this Beckmann rearrangement will be taken place. Here benzophenone oxime C6H5 C double bond NOH C6H5 in presence of acetic anhydride, acetic acid, hydrochloric acid will be converted into C6H5 NH double bond O C6H5. So benzanilide will be formed from benzophenone oxide in the presence of acetic anhydride, acetic acid and hydrochloric acid. So I hope you could understand the reaction Beckmann rearrangement. Meet you soon. Thank you.